Hello, welcome back. This is Balu here from SPTech Bangalore. Today we are going to look into the third chapter of your Unit 1 in Software Engineering. The title of the chapter is called Computer-Based Systems Engineering. Now, if you have not gone through the session 1 and session 2 of my video series, I would recommend you to go back and review the session 1 and session 2 and come back and look into this particular session. So what do we have in this particular chapter for you today? We are going to look into the session objectives very quickly. We are going to define what a system is and what are the different types of a system. And we are also looking into the fact what are systems in their environment. We shall look into the systems reliability engineering factors, and we shall also throw some light on the process of system engineering, and we'll also see how people and computer systems and organization and human factors affect the performance of the system, and also we'll look into system procurement. Okay, now we shall start the session by defining what a system is. Now you have heard of many kinds of systems in your day-to-day life. You have heard of education system. If I can give you more examples, if you have heard of political systems, you have heard of circulatory system in a human being, digestive system in a human being. Now system is a very abstract word, okay, and it has to be used specifically for the kind of system what you are going to do on a day-to-day life. Now we are not going to deal with the very abstract systems like government systems or political systems. Here we are more concentrated on computer-based systems. Now, what is a system and how do we define it? Now, as you can see from here, a system is a collection of interrelated components that work together to achieve some objective. Now, very important. Now, what is the outcome of a system? The outcome of a system is to achieve an objective or to achieve a set of objectives. Now, if I can give you the examples of some system here in terms of computer terminology. You have an operating system. You know what an operating system is. Now you must have used Windows 8, you must have used Windows 7. So those are the examples of an operating system. You have an information system, something like the World Wide Web. The World Wide Web is a solid example of an information system. And you have a biometric attendance system. Now most of the companies are going for biometric attendance system where the attendance of a employee is taken in the form of biometrics. Now biometrics could either be a thumb impression, or it could be a voice, or it could be even a facial recognition. So now in all these examples what I told you, the output of the system had some definite objectives. What is the objective of an information system? To provide information. What is an objective of an operating system? To ensure that your system works properly, where it basically helps the user to interact with the hardware. And what is the objective of a biometric attendance system? To update the attendance of an employee. Now these objectives are actually related to a particular system, and they vary from one system to another system. And one thing you should note here is all the systems have certain things in common. So what are those common things which are found in these systems are, the systems whatever I have proposed earlier have got something called as software in common, and they have something called as hardware in common. But a system is not just a combination of hardware and software. It could also have other engineering principles which can come into it, which comes as an integrated part of it. So we can see that a system may include software, mechanical, electrical, electronic hardware, and be operated by people. Now if you look into a very complex system like air traffic controlling system, the air traffic controlling system has got not only hardware and software, it has also got mechanical, electrical, electronic hardware imbibed into it. Or if you take one more example, let's say that you have air balloon in a car. So what is an air balloon in a car? As soon as the car meets with an impact, the balloon basically inflates to save the passenger from danger. So in that case, that system basically has got hardware, software, automobile components, and other electrical components embedded into it. Now a system that includes software falls into two categories. Okay, now what are those kinds of categories where we can basically classify the system which has software involved in it? The first one is called as a technical computer based system, and the second one is called as a socio-technical systems. Now whenever you think of a system which has got a software component into it, and those systems can fall into two categories. The first category is called as a technical computer based system, and the second category is called as a social technical system. So we shall see what exactly are these and how they are going to influence us. Now when you take into account the technical computer based systems, as I told you earlier, they include hardware and software. Now example of that could be your mobile phones and TVs. Now you have all smart mobiles. So in the smart mobile you both have a hardware as well as a software. Now where is the software? You have an Android operating system there. Now even televisions are also software embedded, but they come in form of an embedded software. Now in the technical computer based system, you can see here they use it for some purpose. Knowledge of the purpose is not important and is also not the part of the system. Now what exactly is a technical computer based system is, you can use that particular TV for a purpose, but for what purpose you are using, that is not important. For example, you can use a TV to basically watch an entertainment channel, or you can also use a TV for watching an devotional channel. That means what purpose you are using, that purpose is not a part of that particular system. You can use it for variety of purposes. But when you talk of a social technical system, there is a slight difference between these two. Now in case of a social technical system, this social technical system also has got hardware and software as an integrated part of it. Along with the hardware and software, there are few other things which you have to consider. One is the inclusion of an operator. Now operator are nothing but people who are going to use that particular system. So they are the part of the system. And apart from that, it also includes knowledge of how the system must be used. And very importantly, the social technical systems are governed by national laws, organizational rules and policies. Now one example of a social technical system would be your e-learning. Now what is e-learning? E-learning is a learning where you can learn your subjects online. Now as a facilitator, the lecturer will start delivering you lessons online and you're going to learn that. Now in that case, that particular system is basically used for only e-learning purpose. The system cannot be used for any other purpose for marketing or any other purpose for promoting a product, which means there is a definite purpose of that particular system. Unlike television, which can be used for seeing different kind of television programs, here if you have a e-learning system, the e-learning system is only used for the purpose of learning. It cannot be used for any other purpose. And also more importantly, it is governed by organizational rules. Now what do you mean by organizational rules? Now for example, your college is promoting an e-learning system. Now what are the subjects are available in university where your college is affiliated to? Only those subjects are actually put in the e-learning system. That is why they are called as organizational rules. Now you understand what is the difference between a socio-technical system and a technical computer based system. Now socio-technical system is a very wide system. It consists of both social factors and technical factors. Social factors include people. Social factors include organizational rules. Social factors include policies and national laws, and technical factors could include hardware and software. But in case of a technical computer based system, it only include hardware and software. Okay, so once you are clear with this, now I have given you some two examples of technical computer based system. Now you have an operating system here. Now you have an information system here. Now this operating system basically is interacting with your monitor, it interacts with your applications, it interacts with your disk drive, it interacts with your mouse. So basically it coordinates your hardware activity and also interacts with the application and the user. Now if you take an example of an information system, it's a World Wide Web. Now this World Wide Web interacts with various hardware and devices across the world, and the major advantage of using this World Wide Web is it gives you the information on time. The right information is given to the right person on time. And again, the purpose is not clear here because you can use the information system to access any kind of information. Okay. Now this is an example of a socio-technical system, a biometric system. Now why it is called a socio-technical system? Because Now as you can see in this biometric system, it is a combination of hardware, it is a combination of software. Along with that, there are people who actually use this particular system for a specific purpose. Now what is the purpose of a biometric system? The purpose of a biometric system is to mark the attendance of an employee. As soon as the employee enters the organization, he has to just put his fingerprint on this biometric system. The biometric system will recognize the fingerprint of an employee and he will grant access to enter inside the organization. So we can call this as a socio-technical system. And what is the objective of this particular socio-technical system? The objective of the system is to mark the attendance of an employee and also mark the total number of days present and total number of days absent for an employee over a given period of time. So like this you can have many number of objectives. Okay. Now every system have their own environment, which is very, very important. Now you just cannot put a system in thin air. You cannot say that the system is lying in vacuum. That is because on any system you design, those systems they actually exist in an environment. Now what do you mean by environment? Environment basically depicts a boundary of that particular system. Now you can see from here, you have a software system installed here. This software system is governed by certain people and certain hardware devices who are acting as a boundary. For example, you have an email server, you have a printer, you have a database, you have a file system, you have a SAP application here, you have an admin person here, you have a manager here. Now whenever there are people involved, you can call them as actors and you have these hardware devices as resources. Now this software system will only work within this boundary. That means an accountant can communicate with the software system, a manager can communicate with the software system, and an admin can communicate with a software system. And this software system has an access to this email server only, to this printer only, to this database only, and to this file system only. Now if I have an external entity somewhere here, now if this external entity wants to interact with this particular system, it's not going to be possible because that external entity is not a part of this particular system. It is outside the environment of the system. So the environment basically defines the boundary of that particular system. Now once you understand the environment of the system and once you understand the concept of what a system is, now it is very important for you to understand the reliability of a system. The reliability of a system is defined by a separate discipline in engineering called as reliability engineering. Now what exactly you mean by reliability? The classical definition of a reliability means consistent performance of the system, which basically means trust. Now when do you say the system is reliable? When the system is trustworthy. That means that system should be able to perform what it is supposed to perform. Then you can say that the system is reliable. Now I am giving you an example of an air ballooning system in a car. Now what is the important objective of an air balloon system? As soon as the car meets with an accident, the air balloon should basically inflate, and that inflation of the air balloon should protect the passenger from an injury. Now if this happens instantaneously, as soon as an accident occurs, then we can say that the system is reliable. Suppose if the inflation happens after 2-3 seconds of an accident, that means the system is not an reliable system. So now, how do you define the system reliability? The system reliability is defined as the probability that a system, including all hardware and software, will satisfactorily perform the task for which it was designed or intended for a specified time and in a specified environment. Very important. That means when we say that the system is reliable, what does I actually mean? I actually mean that that system works as per my given condition, it works on a specific environment, and it works on a specified duration of time. Okay. Now this reliability is influenced by 3 factors. The first one is called the hardware reliability, the second one is called the software reliability, and the third one is called as an operator reliability. Now the system is not just combination of hardware and software, it is a combination of multiple things. So what are those multiple things? We shall see it later. Now any system reliability depends upon the 3 factors, that is hardware, software and operator reliability. Now what is hardware reliability? We know that a system has got some hardware components inside that. Now if this hardware components goes bad, now why does the hardware component go bad? The hardware component could go bad because there is a malfunctioning of the hardware, or the hardware component can also go bad because the hardware wones out. Now because of this, the reliability of the system comes down, and there is also a concept where we have that the software reliability also plays an important role in the overall reliability of the system. So in case of a software reliability, there is no wearing out of a software, because software does not wear out, but software actually depends on the hardware. Now if the hardware gives wrong values to the software will start computing the wrong values and will start giving you wrong results. And when the software starts giving you wrong results, then the operator who is basically working on that particular system will look at the wrong results, and he will try to do certain activities which may stall the entire system. Now I will give you one simple example. Now if you take a biometric system itself, now this biometric system will have an hardware component called a sensor. Now what is the main purpose of a sensor? The sensor is a device which basically senses your thumb impression, and it will verify in the database whether this particular thumb impression is present or not. If the thumb impression is present, then we can say that the employee's attendance is on, else the employee's attendance is off. Now if this sensor is not working properly, what does it happen? It may give a wrong value to a software, and that software could mark a wrong attendance of that particular employee. The employee may get panicked. Once the employee gets panicked, he will try to misuse that particular system in such a way that the entire system comes to a halt. So you have to ensure that there is certain degree of reliability which has to happen, and that reliability analysis has to be done. See, we also call this as the probability impact analysis. Now what do you mean by probability impact analysis? What is the probability that a hardware can fail in a particular system, and what is the impact of the failure of the hardware on the entire system? Now hardware failure probability could be around 10%, and the software probability could be even lesser than that. So system reliability engineering talks about the reliability of the entire system. Okay. Now when you talk of an system engineering process, now it has got a definite life cycle. Now just like how you had the life cycle of a software, the system engineering process also has got a life cycle. Now let us not confuse between a software and a system. Now system is very different from a software. A software is an integrated part of a system. Software is only a component of a system, nothing else. But system is as a bigger entity. Apart from software, it has got hardware, it has got certain other things which we have discussed before. Now if you want to engineer a system, it has to follow a process, and the process would be something like this. You have a requirements definition stage, you have a system design stage. Now this system design stage has got furthermore stages. Then you have a subsystem development stage, you have a system integration stage, you have a system installation stage, you have a system evolution stage, and you have a system decommissioning stage. So these are some of the stages what we have in system engineering. Now how do you define a system engineering process? It is the activity done for designing, developing, implementing, and maintaining socio-technical systems. Now whenever you talk of system engineering, we are only talking of socio-technical systems. Now what is a socio-technical system? It's a system which is governed by organizational policies. It's a system where people are a part of the system. It's a system which includes both hardware and software and any other components as well. And more importantly, it has a definite purpose. Right. Now system engineering is not easy. It is not as easy as software engineering, because in software engineering only software engineers are involved. But in case of system engineering, there are many people who are actually contributing to the building of a system. For example, you have an engineer from architecture coming in, you have an engineer from civil department, you have an engineering from electronics department, you may have an engineering from electrical department, you have an engineering from mechanical department, then you have a software engineer who is dropping in systems engineering. You also have people from ergonomics. So there are people from varied disciplines who are actually contributing to systems engineering. Now what will these varied disciplined people do? Now I again take the example of a biometric system. Now if you want to develop such a system, You just not need software, you also need hardware. So you need hardware engineers to actually design the hardware. You need software engineers to design the software of a biometric system. You need civil engineering people to actually install that particular biometric device in a particular wall of an organization. You need people from architecture to define and tell you whether it is the right position for that particular device to be mounted or not. You need electrical engineering people to actually ensure that the electrical connections to that particular system is proper or not. And finally we have ergonomics. Now what is ergonomics? Ergonomics basically means it is a study where how people can properly and user friendly operate that particular system with ease. So there has to be an ease of operation. So you cannot build a system where people cannot operate it freely. So ergonomics deals with that. So ergonomics are also becoming an input to an systems engineering process. We can also say that it's an interaction of among human and other elements of a system. So now when you look at this particular diagram, it is very easy for you to understand that it is not just software engineers who are contributing to system engineering. There are people from varied disciplines who are contributing to systems engineering, and each person who is representing each engineering department would be an expert in his own domain. And it is very important, if a project manager is actually designing a systems engineering project, it is very difficult for him to take ideas from various engineering disciplines, combine them, and to actually build a system which can readily be used and deployed. So this is a slide which talks about what are the various disciplines involved in system engineering. Fine. Now we will look into stage by stage what happens in the system engineering process. Now I have explained you the system engineering process. I have given you the various steps here. Now we'll look into what happens in requirements definition through what happens till system decommissioning. Okay, now we have already seen systems requirement definition. The requirement definition was a word which we used in the waterfall model. Now what do you mean by requirement definition? Understanding the requirement. Now whether you want to build a software or whether you want to build a system, both requires requirement. Now in case of a system also you would require requirements. Now the requirements are gathered in a process called as a system engineering process. Now the system engineering requirement document will basically specify what system should do by consulting end users and the customers of the system. So basically you talk to the end users of that particular system and ask them what would be the requirements given from your side to that particular system, and here we only document the abstract functional requirements. Now what do you mean by abstract functional requirements? Abstract basically means high level requirements. That means you don't get all the requirements at one go, you only get some specific set of requirements. Then you have to take down those specific set of requirements, break it down further and further till you actually get the actual set of requirements. Now we should also be concerned about system properties in terms of availability, performance and safety. So in the system requirements definition we only define the high level requirement. You don't define the low level requirements. So along with the high level requirements we also talk about the properties in terms of the availability of the system, the performance of the system and the safety of the system. Now there is a difference between availability and reliability. Now what is the meaning of availability? Availability basically means system should be available when required. That is called as availability. And reliability means you should be able to trust that particular system. Now when you take an example of an air balloon systeming in a car, now the moment the car meets with an impact, this system should be available, which means that availability talks about actually the system should come into an active state, and the moment the system comes into an active state it should be reliable, which means it has to be trustworthy, which means it should perform the actions it is supposed to perform. So availability characteristics are actually defined in the system requirements definition, and also the performance. Now what is the performance? How fast the system is responding to me or any other kind of inputs given to the system, that is called as performance. And the third characteristics would be in the terms of safety. Now apart from these characteristics, there are certain characteristics which are also has to be mentioned in the system requirement document, and that would be characteristics that should not be exhibited by the system. Now we call this as the requirements which are outside the scope of the project. Now it is very important to write down those list of characteristics which are not the part of the system and the characteristics which are also the part of the system, and all these are actually documented in systems requirement definition. Now once you are done with that, you go to the next stage of your system engineering process, which is called as system design. Now this system design in turn has got many sub stages. Okay, now we shall look into these sub stages in depth before we actually go to subsystem development and subsystem integration. So what and all we have in the system design process. Now this system design process in turn has got partitioning of requirement as one stage, identification of subsystems as another stage, assign requirements to subsystem as another stage, specify subsystem functionality, and define subsystem interface. And note that between two stages you have a double-headed arrow, which means that there are some data which is passing from the one stage to another stage, from backstage to the front stage, so that you are refining that particular process as and when you are actually progressing towards the development of the system. So what are these stages? The first stage is called partition requirements. Now this is a very important stage. Now you know that in the requirement process you have got many requirements. Now what you have to do is you have to partition that particular requirements in a proper order. For example, you are building a biometric system. Now what are the requirements of a biometric system? You should have some hardware component, it should have some software component, you should be able to identify the thumb impression of a particular employee. Now that thumb impression has to be stored in a specific database. Now the database has to be searched for that particular thumb impression, and if the thumb impression matches with the thumb impression sensed by the sensor, then the employee should be marked as present, otherwise he should be marked as absent. Now this present or absent should go into an HR system. Now all these things becomes your hardware and software requirements. Then when you talk of architectural requirements and civil requirements and electrical requirements, we talk about how much electricity that particular biometric system would use, or what is the wattage of that particular biometric system, and what will be the size and dimension of that particular biometric system, where it has to be installed on your organization, and how should the connections be given. So now you can see that the requirements are getting partitioned. Now once the requirements are getting partitioned, now these separate set of requirements become different subsystems. So you have one subsystem for electrical department, which means that this biometric system will have a subsystem of managing the electrical components, one subsystem for managing the electronic components, one subsystem for basically managing the hardware component and a software component, and so on. So that means once the requirements are partitioned, you have to partition those requirements in such a way that the specific set of requirements become a subsystems. Then you have to assign the requirements to the subsystem and specify the functionality of the subsystem, what that subsystem will do, and finally design the subsystem interfaces. So what you are trying to do in system design basically is you are trying to give a design of the entire system by identifying the number of subsystems that particular main system would contain, and those subsystems will basically come into picture depending upon the partitioning of requirements. So now once you are done with the systems design, now before we actually proceed further, I want to give you some more information here, and that information is respect to the design. Now in the design we do something called as modeling. Now we call it a system modeling. Now this is a solid example of a system modeling where we do a diagram called as a modeling diagram. Now here I am using an example of an intruder alarm system. So this intruder alarm system has got many subsystems. Now you can see here you have a movement sensor, you have a door sensor, you have a siren, you have a voice synthesizer, you have a telephone caller. Now who is an intruder? An intruder is a person who tries to break into any kind of a system. For example, you have a robber entering into your house, and that robber can now be called as an intruder. Now the moment a robber tries to open the door of your house, the alarm should ring or you should get a telephone call. Now how do you do that? That is actually done using an intruder alarm system. Now you have different subsystems here. You have a movement sensor, you have a door sensor, you have a siren, you have a voice synthesizer, and you have a telephone caller, which is actually connected to an control center. Now apart from this, which is being shown as a form of a block diagram where you have number of subsystems and the interactions between the subsystems, we also represent in form of a table what each subsystem is doing and what is a brief description of that particular subsystem. For example, you take a movement sensor. So what does a movement sensor do? It detects the movement of people within the premises. The moment you have an intruder alarm system inside your house and that alarm system is active, the moment anybody moves inside that particular area, automatically the intruder alarm system will become active. Or there could be a door sensor. What does the door sensor do? Basically, it detects the opening of the door. The moment somebody opens the door, basically it's a sensor which basically detects the opening of a door, and it will in turn call an alarm controller. So what is an alarm controller? It controls the operation of the entire system, and alarm controller in turn will basically signal a siren, and siren will emit a loud warning stating that there are some intruders inside your house. And if you are not active to the siren, and if you are somewhere else, and if you are not able to hear to the siren, there could be a voice synthesizer where automatically the alarm controller will call up your mobile and it will talk to you and say that there is an intruder which has been detected in the particular location of your house. And that is actually done. Apart from that, it will also call initiate a subsystem called a telephone caller, where it will initiate telephone calls to police and security. Now this is how a system modeling is done, which actually comes in the design of a system. Now you can see that now all these are different requirements. Now each requirement is given by different people, are the users of the system, and there are different disciplines of engineering involved in this, and all these requirements are partitioned into various subsystems. Okay, once you are done with the system model, sometimes you also talk about the architecture model. Now what is an architecture model? An architecture model is a even more descriptive model than a system model. See, in the system model, we only talk about the subsystems and how subsystems are interconnected, but in the architectural model we actually show that data which is flowing between the two subsystems, and it is also represented in the form of a block diagram. So an architectural model cannot be understood by everybody. It can be understood by only by people who have some knowledge on how to read an architectural model, but a system model can be understood by any layman. That means even a customer can understand what a system model is and what are the functions of the various subsystems. Okay. Now once you are done with the design, the third important step in your system engineering process is your subsystem development. So what do we do? Now you have got the requirements, you have partitioned the requirements. Now after partitioning the requirements, you have defined the subsystems for each partition. Now it is time to develop the subsystem. Now either you can develop the subsystem on your own, or you can actually give for a contract to a third party to develop the subsystems. So one thing you should know that all subsystems are usually developed in parallel. Now suppose if you have a system which comprises of around 200 subsystems, all the 200 subsystems has to be developed parallelly. For example, now you are actually going to develop a biometric system. Somebody has to develop the casing. The casing is a subsystem. Somebody has to develop the hardware of that particular biometric system. That's a separate project. Somebody has to develop a software. That is a separate product. Now all these are different subsystems of a biometric subsystem, and all these subsystems has to be developed parallelly, right? So once the subsystems have been developed, now we come to the third stage of systems engineering process, which is called as system integration. Now you can see that now these are the different subsystems. You have A, B, C, D, E, F, G and H. Now these are various subsystems. There could be n number of subsystems. Now all these subsystems are actually connected with each other, and once they are connected with each other, they become the complete system. So what is the meaning of a system integration? It is a process of combining all the subsystems together to build and make up a complete system. Integration itself means combination. It combines the various subsystems and it builds the main system. And that's not only the thing which happens in the system integration. Apart from that, you are also going to check the behavior of the system. That means whether all the subsystems are working properly or not. That is, once integration is completed, an exhaustive system testing takes place to check the behavior of the system and also check for interface errors. Now when these two subsystems are interconnected with each other, I have to check whether these two subsystems are working properly or not. Now there could be some problem of interface between subsystem A and subsystem B. For example, there could be a problem with a sensor system and a software system. So that interface could be a problem for me. Now I need to check and find out whether those interfaces are working properly or not. So one thing you have to understand here, that if all the subsystems are working properly, then the main system would be working properly. That is what is called by reliability engineering. Good. Now once we are done with system integration, the next thing is called as system evolution. Now what is evolution? See, after the integration you go and install that particular system, or you hand over the product to the customer, but your job doesn't end there. Now what happens? There will be changes in requirements. Sometimes the customer will come back and say change certain portion of the system, and you may have to go and rebuild the system once again, or you may have to actually change certain things in the system to match the requirements or demands of a customer. So that is called as evolution. For example, now you have actually built a biometric system. It is all working fine. Now employees are marking their attendance on a biometric system. Now the customer comes back and says that now I would want this biometric system to automatically open the door as soon as the employee comes in, and close the door once the employee enters inside the organization. Now this requirement was not there in your earlier project, so now you have to build that particular requirement in the biometric system. So this is called as system evolution. That means you are actually increasing the capacity of the system day by day or month by month, depending upon how frequent that particular requirements come to you. Okay, sometimes what happens is now there are no requirements at all, and the system becomes a very critical factor of that particular organization. They cannot live without it. Then that becomes a legacy system of that particular organization. Okay, as you can see here, as the system ages off and are critical to the organization, they are called as legacy system. That means they become the most important systems of the entire organization structure, which means the organization cannot live without it. They are called as legacy systems. Right. Now there is one more stage in the system engineering, which is the last stage, is called as system decommissioning. Now what do you mean by decommissioning? Removing the system from the particular place. Now for example, we say that decommissioning is a stage where taking the system out of its service after the end of its operational lifetime. Every system has a lifetime. Now once we find that the system is saturated and it is no longer useful, we are going to decommission that particular system. Now when we are doing that, you just cannot simply decommission and throw it away, because we have environmental hazards creeping in. So since the system is a combination of hardware component, it has to be properly disposed, and this particular system has got huge amount of data inside it. Now you have to ensure that the data has to be transferred properly to a new system. For example, now all the employee records in a biometric system are stored in a database. Now you are going for a new biometric system which is coming into picture. So what will happen to the data in the old biometric system? It has to be taken and exported to the new database. So this process of moving from the old system to the new system, or discarding of the old system and coming to a new system, is called as system decommissioning. Now those were the actual stages of systems engineering. Now there are certain influences which happens on a system. For example, there could be what could be the influence of a system in terms of a process change, or what could be an influence of a system on a job change, or what could be an influence of a system on an organizational change. Now let us understand what is a process change. Now you are building a system. Again, I'll take an example of a biometric system. You are building a system. Now once you have built a system, before biometric systems were implemented in an organization, you had an manual attendance entry system where the employee used to actually enter or sign in attendance register. Now the signing process is eliminated, and now the biometric is coming into picture. Now that is called as a process change. That means the employee should get adjusted from an old process to a new process, and there could be a job change. Now earlier there could be a security who used to sit with an attendance register, and the security in front of the security the employee used to mark the attendance. But now what has happened basically is, now there's an installation of a biometric device. Now the security does not have any job, so he has to, there is a concept of a job change there, which means that job what the security was doing earlier is no longer being done because of the implementation of this biometric system. And there could be an organizational change as well. The organizational change could be how exactly the organization is affected overall after the implementation of the new system. So human factors, organizations, people, they all play an important role on the computer, on the systems which has been implemented. Now there is another knowledge area which is called as an system procurement, which is very important. Now how do you procure a system? Now the system procurement is where we have to think from a buyer's perspective. Now what do you mean by a buyer's perspective? It is a process of acquiring the system to meet some need. Now I want to install a biometric system. Now how do I install it? Whether I am going to build a system right from scratch, or I am going to the market and I am going to buy that particular system for me. Now this is what you mean by make or buy decision. Either you are going to build it on your own, or you are going to go to the market and try to buy a biometric system for you. So buying the biometric system is called as an off-the-shelf decision, where you are going to buy the biometric device, or you are going to build it on your own. Now whether you want to do that, then you need to have an architectural design. You need to have the design of that particular system. So now there is a separate process involved here, which is called as a system procurement process. Now this system procurement process has got two stages. One is you have survey market for existing system. Now you have requirement, you want to buy a system. Now you are going to survey the market and find out, are there any systems available in the market as of now. If they are already available, then check whether those requirements of the system which are available matches with your requirements. Choose the system and finally choose the supplier, pay the money and get the system. Now when you do that, the requirements given by a biometric system or any other system you want to buy may not match with your exact set of requirements. In that case, you may have to go and build a system on your own. So how do you build a system on your own? Then you request for a tender. You basically float a tender where various organizations who are in the capacity of building such complex systems will come and talk to you and say that they'll basically express their interest in building that system. You select the tender, you negotiate the contract with them, and you give out the contract for the development of the system. So this is called as system procurement process. Okay. Now here there are two things which you have to understand. Now you are the system customer, because you are the customer who are going to buy the system. For example, I am going to buy a biometric system and I'll have a principal contractor with me. Now the principal contractor will in turn have subcontractors. Now who are these subcontractors? Subcontractors are the people who will supply subsystems to the principal contractor. I will only be talking to the principal contractor. The principal contractor in turn will talk to all the subcontractors. For example, if I want to buy a biometric system, the principal contractor has to talk to an electrical engineer. He has to talk to a civil engineer. He has to also talk to an architectural engineer. Why he has to talk to an electrical engineer or an electrical contractor? Because he has to give the electrical connections. Then he has to talk to a civil engineer because he has to drill holes in the wall to install a biometric device. And he also talk to a architectural engineer to ensure that the aesthetics of the building is maintained. So now as a system customer, I'll only be talking to the principal contractor. The principal contractor will be responsible for subcontracting that particular job to various other subcontractors for building that particular subsystem. Or in other way around, as a system customer, I will have approved list of subcontractors, and the principal contractor has to choose one among them to basically implement that particular job. So that's it for this particular session. We have learned in depth what is system engineering process and what are the challenges involved in the system engineering process, and more importantly we have also learned about system procurement and reliability engineering per se. So we will look into the further sessions in my next video session. Till then, keep watching. Please subscribe to our YouTube channel SPTech and also follow us on our Facebook SPTech BANG. Have a nice day and very warm evening. Bye bye.